in this lesson we are going to be talking about translations of functions. So first of all, some vocabulary you need to understand is that a parent function is the simplest form of a function. Families of functions would be each function is a transformation of a parent function. So let me explain this further. A family of function might be like linear functions. So that would be y equals mx plus b, that type of a function. The most basic of those functions would be y equals x. That would be called the parent function of the linear functions. Now, if you have transformations of this function, that would be like y equals 2x, or y equals 2x minus 3, something like that. And these extra numbers in these equations would move the y equals x around. So here, this is your parent function, and these are some other functions in that family of linear functions. Now, the word translation, that's an important word, and that's kind of the fancy word for a vertical, horizontal, or a right or left shift of a function. So when we move a function right, left, up, or down, that's called a translation. And then a reflection flips the graph over the x or y axis. So a reflection is a flip. Now, it says in the first question, how are the functions y equals x and y equals x minus 2 related? So just real quick, I want to graph the function y equals x. So if you made a little xy chart to graph that, if x is 2, y would be 2. If x is 1, y would be 1. If x is 0, y would be 0. If x is negative 1, y would be negative 1, and so forth. So if you plot those points, you have a line, and this is your parent function of the linear functions. It's just your most basic. And you would draw a line through here that would keep going. Okay, now let's plug in some points over here for the function y equals x minus 2. So we will put in the points 2, 1, 0, minus 1, minus 2. So 2 minus 2 is 0. 1 minus 2 is a negative 1. 0 minus 2 is negative 2. Minus 1 minus 2 is minus 3. Minus 2 minus 2 is minus 4. So we graph that. We have 2, 0. Over 1, down 1, 0, negative 2, negative 1, negative 3, negative 2, negative 4, and so this is the transformation, or we would call it a translation to be more specific. And it says, how are their graphs related? Now, when you look at this, notice that if you take this point, it gets shifted down 2. All of these points are just shifted down 2. So when you have y equals x compared to y equals x minus 2, we would say that the minus 2 means that you have a translation. That's the fancy word for a shift of down 2. So the original graph went down 2 units. In the next problem, it says, what is the graph of y equals x squared minus 1? If you translate it up 5, well, let's just write that out. X squared minus 1, but if you translate it 5, that means that you are going to go up 5 units. And to graph it, let's simplify that. And so that's the equation. So we will make an xy chart. We'll put in 2, 1, 0, minus 1, minus 2. So if we plug in 2, 2 squared is 4, plus 4 is 8. Put in 1, 1 squared, plus 4 is 5. If we put in 0, we get 4. Now if you put in a negative 1 squared plus 4 would be 1 plus 4, so you get 5. And if you put in negative 2 right here, that would be a positive 4. Plus 4 is 8. So x squared means it's quadratic, so that is going to be a U shape. So over 2 up 8. Over 1 up 5. 0, 4. Negative 1, 5. And negative 2, 8. So this is the graph. All right, in this next slide, it says the graph shows the projected altitude f of x of an airplane scheduled to depart from an airport at noon. If the plane leaves 2 hours late, what function represents this transformation? So f of x is the black graph here. And so starting at noon, so the time is 0, the altitude is 0. And it very quickly increases the altitude, levels off, goes up a little bit more, reaches its flying altitude, and then it starts the descent. If it leaves at 2 o'clock, the starting time is here. So what you'll notice is that the y values of the delayed flight correspond to the x values 2 hours earlier. So if we compare f of x, the original equation, compared to f of x minus 2, this new graph is shifted to the right 2. So when you see x minus 2 in parentheses, that is a translation 2 units to the right. Now when you see a negative here, that may seem a little confusing because you're going right and not left, but just a little note here, and we'll be talking about this in tomorrow's lesson. This is the standard equation for an absolute value equation. And so just a note here, the A is going to represent a stretch. The number in front will represent either a stretch or a compression, which we'll talk about in a little bit. This number inside the absolute value, or like in this problem, inside the parentheses, that represents a left-right shift. And because there's a negative always in the original equations, if it's a positive value you're putting in, it's going to appear as a negative. And so it's always the opposite of what the sign is as far as right or left. And then the number at the end, that's going to represent your up-down translation. And so if this is a plus 5, you will go up 5. If it's a minus 5, you would go down 5. Here is another example of this. Here we have the graph of y equals the absolute value of x, and I have that in the black right here. And if you graph that, you'll see, or make an xy chart, you'll see why that's the graph. And then next to it in red, I have the graph of y equals the absolute value of x plus 2. So you'll notice when I plugged in points, when x was 3, y is 5. When x is 2, y is 4. When x is 1, y is 3. When x is 0, y is 2. And if you scooch over here, when x is a negative 2, y is 0. And when it's a negative 3, it starts going back up. So when this was a plus 2, the graph actually shifted to the left 2. So even though it's a plus 2, this number inside of the parentheses or the absolute value shifts it to the left 2. All right, now we'll talk about reflections. So for the function f of x, the reflection in the y-axis is f of negative x. So let's talk about that. So this is your function f of x right here. The y-axis, let me get a different color here, is this right here. So we are going to, remember, a reflection is like a flip. So if you flip this point over the y-axis, this point has a coordinate of positive 1, 1. On the other side, it has a coordinate of negative 1, 1. Notice the x value changed from positive to negative when you did a reflection over the y-axis. So you're going to have to use this when you do those problems. Now, if you flip over the x-axis, that is negative f of x. So here is your x-axis right here. I'll make a wiggly line. And so if you're going to take this and flip it over, the y value changes from positive 1 to negative 1. So the positive y's are up here, the negative y's are on this part. So the y value changes. So you put a negative in front of the f of x. Remember I told you that when you see f of x, think y. So you want the y values to be negative. So here's an example. It says let g of x be the reflection of f of x equals 3x plus 3 in the y-axis. So f of x is 3x plus 3. Now, g of x is going to be the reflection in the y-axis. Let me just draw a little picture right here. So if we reflect over the y-axis, that means the x's are going to change. So we have to put in a negative x, which means you take this function and instead of positive x, you substitute in a negative x. And then just simplify that, so that would be negative 3x plus 3, and that's your answer. All right, next one says, let h of x be the reflection of f of x equals 3x plus 3 in the x-axis. What is the function rule for h of x? So this time, we are going to flip over the x-axis right here, so the y's are going to become negative. So g of x will equal negative f of x. Remember I said f of x is like y. So what we want to do is have a negative and then f of x. Well, what does f of x equal? It equals 3x plus 3. So you substitute 3x plus 3 in right here, but the whole thing is negated. So you put parentheses around it. And then lastly, we will distribute the negative through. And there's your final answer. That is what g of x is equal to. All right, next, some more vocabulary words. A vertical stretch of a function multiplies the y values of a function by a number greater than 1. A vertical compression reduces the y values by a factor between 0 and 1. So in other words, it's a fraction between 0 and 1. So if this is your regular function, a stretch would multiply it by 3, so your outputs would be 3 times bigger. If this was your regular function, a compression would multiply it by like a fraction. So like in this case, this looks like it's times a half. It's half the size, so it flattens it. So here's an example. It says the graph of g of x is the graph of f of x equal 4x compressed vertically by a factor of 1/2 and then reflected in the y-axis. What is the function rule for g of x? So you start with 4 of x. What you want to do is do one step at a time. Compressed vertically by a factor of 1/2. A compression, we just said, is multiplying. So you multiply by 1/2, which gives you 2x. And the next step says then it's reflected in the y-axis. So again, this is the x, this is the y. So if you go over the y-axis, the x's are going to change. So we have to put in a negative x right here to show that it's reflected. And then to simplify, your equation is negative 2x, which they say that's g of x. Sorry, that got a little crowded. Next problem says, what transformations change the graph of f of x to the graph of g of x? And again, we want to look at one change at a time. So here we have 2x squared. Here we have 6x squared. This is stretched by a factor of 3 because you multiplied 2 times 3 to get 6. So you would write first, there is a stretch by a factor of 3. And then this is just 2x squared, but then this is 6x squared minus 1. Well, that minus 1 means it's a translation down 1 unit. So remember, the number at the end is going to be your up-down change. Here are a few more problems. It says describe the transformation of the parent function f of x. Well, g of x equals f of x plus 6. The number at the end is your up-down change, so we call that a translation up 6. The next one says h of x is equal to 0.25 times f of x, so that will be a stretch because we're multiplying by a factor of 0.25. This next problem this is going to be a translation, but notice the -4 is in the parentheses. So that is going to be a right-left translation, and because it's a -4, you're going to the right 4. You do the opposite of what you think it would be. So this is a translation 4 units to the right. And here, the x's, you are negating the x's. So here you have positive x, over here you have negative x. So you are flipping it over the y-axis, and our fancy word for that is a reflection over the y-axis. All right, so this next equation says the graph of f of x equals -2x is shown. Describe and graph each transformation. So this one is saying, and we're not going to graph it, but we'll just describe what's happening. Inside of the parentheses, it says it's x plus 1, so we take the opposite sign, so that means we're going to go 1 to the left, and this means we'll go 2 down. So all the points will go 1 to the left and 2 down. So for example, this would go 1 to the left and 2 down. This point would go 1 to the left and 2 down. This point would go 1 to the left and 2 down. So the new one would be over here. This next one is a stretch. So you would take every value times 2. So this is a stretch by a factor of 2, and then you would go up 1. All right, this is the assignment. So page 104, 10 through 12, 19 through 21, 23 through 33, 51 through 54, and 58. I'm going to work out a few of those problems out of each group just to help you get started. Number 10 says, how is each function related to y equals x? Graph the function by translating the parent function. So number 10 is y equals x minus 3. So the first thing you do is graph the parent function. Remember, the parent function is y equals x. So that would be 0, 0, 1, 1, 2, 2, 3, 3. All right, so that's your parent function. And then y equals x minus 3, so think about what that's going to be. That is going to be a translation where every value goes down 3. So then just take the parent function and take every point and move it down 3. And there is your new graph. So that's all you do. If this would have said x plus 5, you would have taken every point from the original parent function and moved it up 5. So that's what you'll have to do on the next problems. Number 19 says y equals x minus 4 quantity squared. And the parent function, it's quadratic, so the parent function, we'll do that in green, is y equals x squared. So if you made an xy chart, you'd have x is 0, y is 0. For 1, if x is 1, y is 1, x is 2, y is 4. If x is -1 quantity squared is a positive. -2 quantity squared is a positive. So this is what the parent function of a quadratic equation looks like. Here in the new function, it says x minus 4, the quantity. So this -4 means you're going to shift or translate 4 to the right. So every point is going to go over 4. So the actual then, the graph, is right here. That's the one you want to have. That's your answer. All right, number 23, going down to that group, it says write the function rule for each function reflected in the given axis. So if you reflect, the first one is in the x-axis. So if we are going over the x-axis, the y's are going to change. So that would be negative f of x, which means it's a negative, and then f of x equals x plus 1, and you distribute. That's your answer. Number 24, f of x equals 3x, and you want to reflect that about the y-axis. And the y-axis would mean that the x values are going to change. So then that would be f of negative x. So that would be 3 times negative x, which is negative 3x. Number 26 says a vertical stretch by a factor of 4. It was y equals x was your original. Number 26, and a vertical stretch by a factor of 4. A stretch just means multiply, so that would be y equals 4x. In 30, it says the original function is y equals 4x. And they want a translation up 5 units and then a reflection in the x-axis. So up 5 units, you would add 5. And then a translation in the x-axis. Over the x-axis, your y's would have to change going over the x-axis. So you have to put a negative around the whole thing. And so your answer would be minus 4x minus 5 for that one. And go ahead and try to work on the rest of that assignment and let me know if you have questions. Here's the key.